Hi. So, last day we started sort of talking about quadratic equations. So we know quadratic equations are equations where the unknown has a squared in it. So for example, x squared plus 3x minus 4 equals 0. Because of this x squared term, that is what makes this a quadratic equation. Now I did also mention that quadratic equations, whenever they are factorized, will always be in the form of two brackets, like the opposite of FOIL. So for example, and this is not going to match with this one up here, x plus 7 and x plus 2, right? So even though this doesn't look like a quadratic equation, it is a quadratic equation. It's just a quadratic equation that has already been factorized. So a factorized quadratic equation will look like that. Now, you'll be delighted to know that the majority of the stuff today is you doing work in your classwork book, but that is what we're going to be looking at. We're going to be really building on what we did last day, but if we're given expressions like this, being able to solve those to give values for x that will make this be true. Okay, so in fact, let's just do a wee example here before we look at the notes. So say I had x plus 5 and x minus 1, and that was equal to 0. Remember, if you have two things multiplied together and the result of that is 0, then at least one of those things has to be 0, because if you're multiplying things and the answer is 0, there just has to be a 0 involved. So either, and I just want to make this point. I know this looks like more than two things, but it's this getting multiplied by this. So this is one thing and this is another thing. So if this multiplied by this gives us 0, then at least one of those has to be 0. So the next line that we would write would be to say that either x plus 5 is 0 or x minus 1 is 0. And then you would work on down the page and solve each of those. So if x plus 5 is 0, x must be minus 5. And if x minus 1 is 0, x must be 1. So things like this would have two possible solutions. Okay, and that, I suppose, is a new thing for us. Normally in maths we just have the one solution and stuff we've been doing so far, but things like this, we can have the two possible solutions. Okay, so let's look at our notes, and I think there's only one example we need to fill in. Let's get that done. So I'm on page 94 here, which is where we left off last day. So in general, we can solve any quadratic equation which is written in this form. So x minus a multiplied by x minus b equals 0, because we know that either this must be 0, which we've said here, x minus a equals 0, or this may be 0, x minus b is 0. And remember, it's and or, like both of them could be 0. So if x minus a is 0, x must be a, or if x minus b is 0, x must be b. So we've got one example on this, and then some classwork. In fact, I'm going to have a wee check and see if there's any of your questions that are a little bit more tricky than this. But let's do the example first. I'm rambling. So example 3, what values of x satisfy the equation? That just means what value of x could you put in here to make this work, to make this statement be true. And because it says values, that's your hint that there's more than one of them. So if x minus 3 all multiplied by x plus 5 equals 0, then either x minus 3 equals 0 or x plus 5 equals 0. So to solve this side for x, all I need to do is add 3 to both sides to get x on its own. So that must mean x is 3 or x equals minus 5. And what that means is that either if I substitute x is 3 into this equation here, we will get 0, or if I substitute minus 5 into this equation, we will get 0, because doing this will make this bracket end up being 0, and if you multiply something by 0 you get 0, and if putting x equals minus 5 in will make this bracket be 0, which again will end up in 0, or both, like both of those would work. Okay. Right, I'm having a wee look at the work that you're going to be doing here. So this first set of questions are all like this, so it's not the 2 brackets. We did some of these last day, if you remember back to that, and there is one like that on page 94 already. Yeah, so like example 1 on page 94. Okay, so just at a quick glance at one of these, if we have x upon x minus 10 is equal to 0, either x is 0 or x minus 10 gives you 0, and then you would work on down from that. The next little set of questions are, okay, just look out, just don't let these ones put you off, like ones like this where it's all letters. Your answer will end up with x equals a letter, right? It doesn't always have to be a number. Now I do want to do one which is quite like these ones here. Technically speaking, we only have to do up to number 30, but I know you like a challenge. So if we do one which is like one of these two, then that means we can give question 31 and 32 a go. Isn't that exciting? So the only difference in these ones is that there's going to be more steps in the solving bit. Okay, now hold on. Okay, so bonus example time. If we had something like this, where 2x minus 5 multiplied by 3x plus 12 equals 0, then one of these 2 brackets at least must equal to 0. So we would say 2x minus 5 equals 0, or 3x plus 12 equals 0. Okay, then we just solve the 2 of them independently of each other. So if I was solving this here, the first thing I would do would be to add 5 to both sides. So 2x equals 5, and then divide both sides by 2. So x is 2.5, or 3x plus 12 equals 0. So we need to get rid of this 12, so take away 12 from both sides. So 3x equals minus 12, and then divide both sides by 3. So x equals minus 4. So the two solutions that work for this are x equals 2.5 and x equals minus 4. So remember, you will have 2 answers for all of these. Okay, right, I will list down what that exercise is and what you need to do. Have fun. See you next time.